Morning, my dear students. Today I am going to discuss about the electrochemistry, and today's lecture is actually upcoming exam oriented lecture. That's why I would not like to discuss the topics very broadly, because already I have discussed all those topics very broadly in my previous lecture. Today actually I would like to discuss about some knowledge based and comprehensive type questions shortly. So look at the whiteboard, my dear boys. What is electrolysis? The process in which electricity is passed through the electrolytic substance and chemical changes take place is called electrolysis. Electrolysis is a redox reaction. If you consider the electrolysis of hydrogen chloride solution, then if you pass electricity through the hydrogen chloride, the positive hydrogen ion goes to cathode and negative chloride ion goes to anode. Chloride ion goes to anode and releases electron to form chlorine gas. My dear students, all of you know that chlorine is diatomic. That's why I have to write here 2, and hydrogen goes to cathode and accepts electron to form hydrogen gas. Here also hydrogen is diatomic. That's why I have to write here 2. If I observe both of the anode and cathode reaction, I will see that in the anode oxidation reaction occurs and in the cathode reduction reaction occurs. Actually, whatever the charge of anode or cathode, always oxidation reaction occurs in anode and reduction reaction occurs in cathode. So I can give the definition of anode: the electrode in which oxidation reaction takes place is called anode, and the electrode in which reduction reaction takes place is called cathode. So I can say the electrolysis is actually redox reaction, because all of you know that oxidation and reduction reaction together are known as redox reaction. Electrolytic substance and non-electrolytic substance. The substances which conduct electricity in their molten or solution state, and after conducting electricity chemical changes take place, are known as electrolytic substances. And non-electrolytic substance, I mean the substances which don't conduct electricity in their molten or solution state, are known as non-electrolytic substance, like sugar. Acid mixed water is a electrolytic substance, because acid mixed water conducts electricity and chemical changes takes place. Actually in the acid mixed water ionizes slightly to produce H plus ion and hydroxide ion. After passing electricity, these negative hydroxide ion are also known as anion. Anion goes to anode. This is universal matter, and cation goes to cathode. This is also universal matter. Hydroxide ion goes to anode. Anion hydroxide ion goes to anode to produce water and oxygen, and cation H plus ion goes to cathode and accepts electron to form hydrogen gas. Actually, after passing electricity or after conducting electricity, the acid mixed water changes chemically. That is why this is known as also electrolytic substance. Faraday's law. If I pass electricity through a electrolytic substance, of course, here if I consider here sodium chloride, a molten solution, chloride ion goes to anode and releases electrons to form chlorine gas, and sodium ion goes to cathode and accepts electron to form sodium metal. So the amount of deposited or dissolved substance in the anode or cathode is directly proportional to the supplied electricity. If I pass more electricity, the deposited or dissolved substance will also be more. So I can write in mathematical language, the W is proportional to Q. Here actually W is the amount of deposited or dissolved substance, and Q is the past coulomb of electricity. W equals to ZQ. Here Z is actually proportionalism constant, which stands for electrochemical equivalent, and coulomb equals to IT. I means ampere into time. So my dear students, I can give an example of electrochemical equivalent. If this is equation 1, if I consider 1 ampere, I equals to 1 ampere and T equals to 1 second. So the W equals to Z. So if I give a definition of electrochemical equivalent Z according to this equation, what will happen? After passing 1 ampere electricity by 1 second through electrolytic substance, then the deposited or dissolved substance, the amount of deposited or dissolved substance is known as electrochemical equivalent. Now if I give you an example about the electrochemical equivalent, you will get a clear concept about it. Electrochemical equivalent of silver is 0.001118 gram coulomb inverse. This is a comprehensive type question, and this is a very important question. Actually, after passing electricity through the silver ion solution, then silver ion goes to cathode. Silver ion goes to cathode and accepts electron to form silver metal. Now my question, how much amount of silver metal is deposited? Actually 0.00118 gram silver metal is deposited in the cathode after passing 1 coulomb of electricity. Now oxidation potential. What is oxidation potential? My dear students, already I have told you, in the anode, this is anode, all of you know that this is anode, and in the anode oxidation reaction occurs after in the meeting point of the anode and electrolytic substance. Oxidation reaction occurs and energy is changed. This changed energy is known as oxidation potential. And in the meeting point of cathode and electrolytic substance, reduction reaction takes place and energy is changed. This changed energy is known as reduction potential. And cell potential is also known as EMF, electromotive force. The sum of the oxidation potential and reduction potential is known as cell potential. But dear students, it is noted that oxidation potential is also known as anode potential, because oxidation reaction occurs in the anode. That is why oxidation potential is known as anode potential and reduction potential is known as cathode potential. Electrolytic cell and electrochemical cell. Electrolytic cell means the cell in which electricity is passed from the external source, then chemical reaction occurs. But in the electrochemical cell, electricity is produced by the reaction of electrolytic substance in the cell. This is the main difference between electrolytic cell and electrochemical cell. In the electrochemical cell, one more electrolytic substances are used, but in the electrolytic cell only one electrolytic substance is used. In the electrochemical cell, solvents is used, but in the electrolytic cell, no solvents used. Reference electrode, the electrode through which the potential of an unknown electrode is measured is called reference electrode. And there are two types of reference electrodes. One is primary reference electrode and another is secondary reference electrode. Primary reference electrode means the electrode by which, the reference electrode by which the potential of an unknown electrode can be measured directly. Then it is called primary reference electrode. Standard hydrogen electrode is an example of primary reference electrode. And secondary reference electrode, the electrode in which the reference electrode by which the unknown electrode, the potential of an unknown electrode can be measured indirectly, is called secondary reference electrode. Calomel electrode is an example of secondary reference electrode. My dear students, now I am going to discuss about the standard hydrogen electrode shortly, but I would not like to discuss it very broadly because I discussed it in my previous lecture. At 25 degree centigrade temperature and 1 atm pressure, hydrogen gas is passed through the along the copper wire to the 1 molar H plus solution in the platinum bead with bubble is called standard hydrogen electrode. This standard hydrogen electrode is connected with the electrode which potential is not known and then the unknown potential, the potential of unknown electrode is measured. Actually, standard hydrogen electrode is used for measuring the potential of an unknown electrode. This is the main uses of standard hydrogen electrode. Standard copper reduction potential is plus 0.34 volt. What does it mean? Actually, my dear students, all of you know that in the reactivity series, you know that the position of hydrogen is above copper. That's why hydrogen is more reactive than copper, and more reactive substance is made anode and less reactive substance is made cathode. That is why here hydrogen electrode is anode and copper electrode is cathode. And copper electrode is dipped in the aqueous solution of copper sulfate, and the concentration of copper sulfate is 1 molar, and it is connected with the standard hydrogen electrode. Then in the voltmeter it is given, and the given value is plus 0.34 volt. And according to the equation, we can write here E naught cell equals to anode oxidation plus E naught cathode reduction. And here in the anode, hydrogen converts into H plus ion. All of you know that acid solution means H plus solution. So hydrogen converts into H plus solution. That's why I have written here E naught hydrogen slash H plus solution plus. Here copper accepts electron. Copper accepts electron to form metallic copper on the surface of cathode. So I have written here copper slash copper 2 plus slash copper, and from the reading of the emitter I can write here plus 0.34 volt, and the oxidation potential of standard hydrogen electrode is 0.00, and the reduction potential, standard reduction potential of copper, then I have written it at the right side and left side, and 0.34 volt is written at the right side. So I can say the standard reduction potential, because it exists in the reduction mode. So I can say the standard reduction potential of copper is plus 0.34 volt. Now standard zinc oxidation potential of is plus 0.76 volt. What does it mean? Here, if you observe the reactivity series of metal, you will see that the position of zinc is above the position of hydrogen in the reactivity series. I mean, zinc is more reactive than hydrogen. So zinc is made anode and hydrogen is made cathode. Here actually zinc converts into zinc 2 plus ion by releasing 2 electrons. So I can write here inert zinc oblique zinc 2 plus, and here proportionally after occurring chemical reaction H plus ion goes to the cathode and accepts electron to form hydrogen gas. So I can write here inert H plus oblique H2, and from the voltmeter I can write here, from the reading of voltmeter I can write here plus 0.76 volt, and inert Zn oblique Zn2 plus 0.0. So inert equals to Zn oblique Zn2 plus equals to plus 0.76 volt. It means oxidation potential, standard oxidation potential of zinc is plus 0.76 volt. Now my dear students, come to the another important comprehensive type question of what is solvage and write the role of solvage in the galvanic cell. In the inverted U-shaped glass tube containing the saturated solution of a special salt, and both of the open side of the glass tubes are injected by cotton or silica gel, and the glass tube is dipped in the both of the solutions of half cells. This instrumental arrangement is known as solvage. Solvage actually complete the circuit of the galvanic cell, and it neutralizes the positive and negative ion both of the half cells. And if I don't use any solvage, the galvanic cell will not get longevity. I mean, after some time or after short period, the production of electricity is stopped. And what is fuel cell? The cell in which electricity is produced through the chemical reaction is called fuel cell. And storage cell, hydrogen fuel cell is an example of fuel cell. Storage cell means, all of you know that lead storage battery, it is used in the vehicle. It is a very common storage fuel cell. Or we use lithium ion battery in our mobile phone. That is also a storage fuel cell. The cell in which the chemical energy converts into electric energy during the discharging and electrical energy converts into chemical energy during the charging is called storage cell. My dear students, now I am going to show you a creative questions. Now here A converts into A2 plus and B3 plus converts into B. Actually, according to the information of the creative stamp, A stands here, A stands for magnesium and B stands for chromium, because the atomic masses of magnesium and chromium are given here. And what is the question? Find out the cell potential of the cell of the star. So anode half cell reaction, magnesium converts into magnesium 2 plus. That's why magnesium releases 2 electrons to form magnesium 2 plus, and chromium 3 plus ion converts into chromium metal by accepting 3 electrons. To make the balance the coefficient of both of the electrons, I have multiplied 1 non reaction by 3 and 2 non reaction by 2. Then the electrons minus 6 and plus 6 are crossed out. 3 magnesium plus 2 chromium 3 plus ion, reversible sign, 3 magnesium 2 plus ion plus 2 chromium ion. Then I have to write the equation of calculation of standard cell potential. We know that standard cell potential equals to standard anode oxidation potential plus standard cathode reduction potential. And in the anode, magnesium converts into magnesium 2 plus. That's why I have written here magnesium oblique magnesium 2 plus. And in the cathode, chromium 3 plus converts into chromium metal. That's why I have written here E naught chromium 3 plus oblique chromium. And in the question, the oxidation potential of magnesium is given, and that is plus 2.36, and oxidation potential of chromium is given, but I need reduction potential of chromium. So it is given as positive value, but I have written here as negative value, as it is the reduction potential, but in the question it is given oxidation format. So inert cell, standard cell potential is plus 1.62 volt. So cell potential equals to inert cell potential minus RT divided by NF ln the molar concentration of reactant, the molar concentration of product and the molar concentration of reactant. My dear students, in case of molar concentration, the coefficient will be the power, magnesium molar concentration of Mg2 plus power 3, and in case of molar concentration chromium 3 plus, it will be power 2, as the coefficient is 2. Then I put the values of inert cell and the values of R. It has to be memorized, 8.314, and the temperature is 298, and the number of exchanged electron is actually 6. That's why I have written here 6, and the 1 farad equals to 96,500 coulomb. You have to memorize it. And ln the molar concentration of magnesium 2 plus ion is given in the stem. That's why I have written here 0.1 mole power 3, and chromium is given, chromium 3 plus is given 0.2 power 2, and cell potential is plus 1.64 volt. That's all about the cell potential of the cell of the stem. Now my question D, B3 plus ion, chromium 3 plus ion. Is it possible to keep the chromium 3 plus ion in the zinc container? Let the zinc container is made anode. So zinc minus 2 electrons equals to zinc 2 plus ion, and chromium 3 plus accepts 3 electrons to form chromium metal. My dear students, to make it balance, I have to multiply the equation by 3, 6, and 3, and 2, 6, 2. Then what will be the cell reaction? The cell reaction is actually 3 zinc plus 2 chromium 3 plus, reversible sign, 3 Zn2 plus 2 chromium metal. Inert cell equals to inert anode oxidation plus inert cathode reduction. Here in the anode, zinc oblique Zn2 plus, and in the cathode chromium 3 plus oblique chromium. And my dear students, this is actually a board question, but the oxidation potential of zinc is not given here. That's why you have to memorize it. The oxidation potential of zinc is plus 0.76 volt. Already I have taught you in my previous questions. Plus the reduction potential of chromium is given. This is in the question is given oxidation potential plus 0.7674 volt, but it is here as reduction mode. That's why I have written here minus. The sign will be opposite, and the result is plus 0.02 volt. As the cell potential is positive, the reaction will occur spontaneously and there will be hole in the zinc container after a definite period. So it is not safe to keep the solution of chromium 3 plus ion in the zinc container. That's all about my lecture on electrochemistry. And my dear students, this lecture is actually very important for your upcoming exam. Goodbye.